Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, today we will continue with chapter 4, vector spaces. Okay, let's say we have two vectors, name vector u and vector v. Okay, how are we going to add these two vectors? So, you can use by using the parallelogram method where you translate the vector v and also vector u. So, this is vector u plus vector v. Okay, and then the difference of two vectors. So, if let's say addition of two vectors is vector u plus vector v, the difference of two vectors is vector u minus vector v. This is also equal to vector u plus with vector negative v. So, this negative sign here means that if let's say you have a vector v, negative v means you have the same magnitude, same length, but with the opposite direction. So, this is vector negative v. So, how are we going to add these two vectors together? Okay, let's say I'm using the same vector u. So, let's say we have vector u like this. And then we have vector negative v. So, would be negative v here. So, how are we going to add these two vectors together? We translate vector u, we translate vector v. So, we have this line. So, this is vector u minus vector v. We move on to scalar multiplication. If let's say you have vector u, scalar multiplication means the vector is multiplied with a scalar. So if let's say you have the same magnitude or the magnitude is twice the original vector. So this one we have vector 2u. If let's say it is half, then we say half u, 1 over 2 u. If let's say you have another vector, the same length but with opposite direction. So this is negative 2u. Okay, now we're going to find a vector, let's say vector pq. Okay, we can represent a vector with a point pq like this, or we can represent with another variable, namely like u. Okay, if let's say we have two vectors, 2 points, p to q. If let's say pq means the vector, the initial point is p and the terminal point is q. Okay, so if let's say you have another vector, namely the name is vector qp. If let's say vector qp means the initial point is q and the terminal point is point p. Okay, we go back to vector pq. Okay, how we going to find vector pq is you have to minus vector q minus with point q minus with point p. Okay, we have to minus OP. O means the position vector. So it's actually from point Q. So x2 minus x1 minus y2 minus y1. Okay, this is the general formula. So if let's say you have QP, the general formula is vector OP or position vector OP and also minus OQ. Let's say I give you one example. Let's say we have point P is 2, 3 and your point Q is 0, negative 2. Okay, find the vector PQ. So you must remember that Q minus P. So Q is 0 minus 2 for the X component, and then the Y component is negative 2 minus negative 3. So your answer is negative 2, negative 5. What is the vector QP? Find vector QP. So if let's say QP means P minus Q, OP minus OQ. So P is 2 minus 0 and then 3 minus minus 2. So we get 2. Okay, look how I denoted the bracket. Okay, if let's say it is a point here, I use a round bracket. But if let's say this one is a round bracket. If let's say it's a vector, I use a angle bracket. Actually, it depends on, we can represent a vector with a bracket like this, or we can just remain with a round bracket. It depends on the book that you use. Since our book reference book is by using round bracket, even for vector, so I will remain by using a round bracket for each example. We continue with exercise number 1. Okay, the same. Okay, I'm going to change this vector to a 3-dimensional vector. 1, negative 2, 0, and then we have V, negative 2, 5, 1, negative 1. Okay, it's the same with, if let's say 2-dimensional, but I just want to use 3-dimensional. Okay, let's say U plus V, so the component for X, 1 plus negative 2, comma, and then component for Y, comma, and then 0 plus negative 1. So your answer would be negative 2, 3, negative 1. Okay. We continue with question number B, U minus V. So minus, you just minus U minus V. 1 minus negative 2, comma, negative 2 minus 5, comma, 0 minus negative 1. So your answer is 3, negative 7, 1. For C, 2, 1, negative 2, 0 plus V. So this one you will get 2, negative 4, 0 plus negative 2, 5, negative 1. So this one you will get 0, negative 4 plus 5 is 1, 0 minus 1 is negative 1. Okay, then you can continue with D. Okay, for the next question, you are given A, B, and C be 3-point space. Okay, find AB. If let's say AB means the position vector OB minus position vector OA. Or you can just remember point B minus with point A. So 0 minus 1, 6 minus 2, negative 2 minus 5. So your answer is negative 1, 4, and negative 7. Okay, and then for BA is point A minus point B. So 1 minus 0, 2 minus 6, 5 minus negative 2. So your answer is 1, negative 4, and then 7. Okay, the question here we have, is it vector AB equal to vector BA? So is it equal? So the answer is not equal. As I mentioned before, let's say this is vector AB, means you have an initial point at A, terminal point at B. But if let's say BA, your initial point is B and your terminal point is A. So if you look at these two, the difference is the positive negative sign. Okay, continue with CA and AC. What is your answer?